Alright, time for another DraftPhysics.com, debatephysics.com, also video presentation. Kind of a effort to create some sort of conversation in the physics community. Is that possible? Can they debate anything or argue anything? So I did find a website called Improbable Matter. The guy sounds very reasonable, quite informed, does a lot of research. So he's talking mostly about fusion and, fusion reactors, their capacity to overcome the hurdles in the way, all of that kind of stuff. And I'd argue that the fundamental physics is where there's this, the real obstacle is that I don't think they have the fundamental physics right, so I don't think they're really understanding what they're gaining and how much they can gain, and all of that. So I, just figured maybe you can get this guy to talk about some of the perhaps physics made a few wrong assumptions in creating its model of the universe. So to make me credible and to demonstrate that I deserve some position, some sort of an invite into the conversation, I'll just show this simulation again, okay, demonstrating how charge, perfectly duplicating the function of charge as it's known to function, using these tiny little number of rules. Okay, so here's a simulation of charge, and there's only 3 rules. Okay, so it's basically just made out of force in the universe, so it's not bent space and it's not wobbles, but it's little discrete bits of stuff moving the speed of light. And there's 2 kinds of it. There's electron force and proton force, which isn't inconsistent with conventional physics in that they create a field for every particle. Okay, I just would claim there are no other particles. So there's just electrons and protons, and there's just electron force and proton force. And I could argue that, I'm showing the creation of deuterium right here, okay? That all you have to do is put electrons and protons into the universe, and they will create deuterium, okay? They'll create a circumstance where there's 2 electrons and 1 proton, and they'll do it, easy. So let me just, all I have to do is move one of these a little bit, and I should be able to restart it, and you'll see that they'll just tend to do what charges do, which is the electrons will repel each other, the protons will repel each other, and electrons and protons will attract. Okay, and the simple rule is basically, I suppose I can put that back on, and I don't know if you can see it on with the, yeah, you can see it with the camera on, with the background. So the idea is if an electron is standing still or moving, and you hit it with force that has some element in the same direction, it binds, the force binds with the electron, and now the electron moves at some speed much slower than the speed of light because the electron has more mass than the elemental bit of force, and so the momentum is just added to the momentum of the electron. So it leaves kind of just collecting force. So the more force that comes in one direction, the electron can collect that force. But it can only collect force in one direction. It can't collect it in both. So if it's moving in a direction opposing a force, then the 2 forces are opposed. Then you get a reflection of the force coming in, and you lose one of the elements that was giving the other one momentum. So the electron then loses a little bit of momentum, and you basically have 2 bits of force free in the universe. Then the one key thing that happens is if the opposite force, so if a proton force hits an electron, it just passes through. It doesn't give it any momentum, doesn't change its momentum, but it comes out an electron force. So if a proton force hits an electron, it comes out an electron force. If an electron force hits a proton, it comes out a proton force. And that leads to something else I'll have to draw, I suppose. All right, so that leads to two perfect radiators. So the proton, no matter what happens, if a red bit hits, it either sticks and moves it, or it reflects. And if a electron force hits it, it comes out an electron force. So the proton radiates only proton force. And no matter what comes in, proton force comes out. Yes, it'll keep some of the force and turn that into momentum if it's in an imbalanced field, but otherwise it just is a perfect radiator. So blue and pink or red force can come in, and only, okay, red force is coming out, and the opposite for the electron. So, a mixed force goes in, only electron force comes out. And this proves the point. Essentially, you can understand fairly quickly that two electrons can't possibly be in proximity to each other, not only because they're both excreting this electron force, but you could understand that all of the proton force coming in these two directions just becomes electron force and creates even more pressure, in the sense that they have to keep reflecting the energy back and forth, or they have to absorb it. So they either move away from each other by absorbing the energy, or they stop moving towards each other because of the energy, and then it reflects, which means it's going to reflect again. So they become very repulsive, and the closer they get, all of this energy would be converted into pressure pushing them apart. So there's very little chance they can ever hit each other. Okay, and the same with the proton. So it creates a mechanism to create the repulsion, and the same mechanism is obviously creating the attraction between the electron and the proton, in the sense that all the force coming out of the proton is completely inert to the electron, can't see it, and all of the force coming out of the electron is perfectly inert, which means all of the electron force coming from this side, okay, going this way, can't get to the electron, and all of the proton force coming from this direction can't get to the proton, so of course they attract. And so this simple mechanism, I called it 2 + 2 + 2 physics, but it's really 3 interactions. So 2 kinds of force, 2 kinds of matter bit, and 3 kinds of interaction: absorption, reflection, and transition. And that creates, okay, put the simulation back on, the behavior that's perfectly consistent with what we see in terms of creating nuclei. All right, so in this sense, this is just creating nuclei in the configuration it's in now, and what it's first creating are neutrons. So I guess that's something to talk about, just a proton and an electron. So the very idea that neutrons are intrinsically neutral or have no charge wouldn't make much sense, because why would they stay in an atom? It's all about charge. It's all about being attracted or repelled. Being neutral, why would it exist in an atom? Why would it stay in the nucleus? Why would it do any of this stuff if it wasn't charged? Because charge is really what holds the universe together. So come on, it really wouldn't happen. So anyway, let's go through some of those details. So there's just a ton of this, of physics reactions that are the implications of these simple rules. But I'm just saying these simple rules diagram charge, and once you've got a charge diagram, then you have a diagram to talk about energy and what the nature of it is. And so I'll do some of that. I figured it was worth showing some of, if you start changing the density of the force, the speed of the force, and the size of the objects that are interacting, you change a lot of the, you don't change the basic function, but you can see a lot of the other variables that are going to affect such a system in terms of creating what looks like, aberrant behavior, but it just comes out of the fact that, once you have a system this active, it's going to create turbulences and different things in it that will make it possible for there to be a lot more motion that you can see. So I don't know if this is a great example, but you can see, okay, with it turned up a bit, now I don't make deuterium as much, and I'm making neutrons. Neutrons are much more stable than the higher form. And so it all really depends on the balance of the speed of the force, the density of the force, the weight of the objects, protons being heavier than electrons, and a lot of other factors that can change how it functions. And I'll try to describe those functions instead of trying to show them. Alright, so something the simulation often produces, or you can visualize. Oh, I have to clean that. Yeah, it should be ready. Alright, so when you do get these objects to combine or get close to each other, you can understand that they become more stable. Alright, well, that's unfortunate. And but the trick is any motion, anything that jiggles them a little. So if they have any distance between them, the argument sort of is that they end up seeing each other. So if this moves over here a little bit, it ends up seeing the other electron, and likewise. So the more noise there is in terms of the more imbalances in radiation. So obviously if they're in a perfect field where it's always the same amount of radiation coming from both sides, then they'll stay in one place. But obviously they're in a world where that's always changing. And especially the more motion you get with a bunch of other particles, the more likely it is you're going to break these simple things apart. And so that's the trick of elevating from these combined objects into an object that's broken, is just the idea of putting in an environment that has enough noise in it where objects end up way out of position now and then because they get hit by pressure from another electron, for example. So in the most basic example, where they talk about the strong force, which is obviously I guess it's not obvious yet, but I'll make it obvious, which is a completely non-existent real force. There's no... Damn it. Yeah, that didn't work. Alright, see if we can see that color. Barely. I don't know what the problem is. Anyway, alright, so we're going to call that the electron that is part of, a neutron. So you have the proton and the electron combined in a neutron, and then you're just going to add this extra proton. And so obviously the idea of getting two protons very close to each other is easily created by just putting an electron in here. So Maxwell could have figured that out, that if you want to get two north side magnets close to each other, just stick a south side magnet in between them and you'll get them really, really close to each other. So you don't need a strong force or anything like a strong force. All you need is an electron between two protons and you've got all you need. And like I said, the only thing that disturbs this is the fact that none of these things are under equal pressure from all directions. So the noisier the field they're in, the more they're jittering, and the more eccentric that jitter is. That is, the higher the frequency of the radiation hitting them, the more likely they are to get imbalanced. So if a gamma ray hits, our energy from a gamma ray, some portion of it hits an electron, it's going to move it much further than it would move it if it was infrared radiation or a radio wave. So the higher the frequency of the radiation they're in, the more likely it is they're going to fall apart, be jiggled apart. And but another key factor is once I have them close together, they're really not storing any energy internally. So now if you want to push one, you have to push the electron and it has to push everything. So now it's just one unit that has a much larger mass when it comes to trying to move it in any one direction. And the other part of that is realizing that, so there's no stored energy here. There's no force bits, doing a whole bunch of work beyond the fact that that any electron force just goes through the proton, turns into a proton force, gets converted into an electron force, and comes out of the proton as a proton force. So it just keeps converting electron force into proton force going this way, and any electron force going this way comes out proton force. So it's still converting, but it's not storing energy, and it's not. And so anyway, it's a very low energy piece of arrangement of matter. But the trick is, if I knock this electron out, so if I hit this electron with a high frequency bit of radiation, I guess I can't use that color either. What happens is now the two protons see each other, and they don't need any force between them, because now when the electron force comes out, a proton force, right? If I get rid of this electron, so I knocked it out, I hit it fast, and it just popped out. And now I have two protons really close to each other. You could understand that now all of the electron force that hits them is going to be converted into proton force. You can't see these, but whatever. So that's electron force. Just put a E on it. Sorry, the colors aren't doing what they should be doing today. Anyway, and it's going to be proton force here. So all of the force that comes in is going to be converted, and now they have a huge amount of force in between them, and so they're going to fly out of here very quickly. That's what's creating the energy, and the energy is really just field energy, and it's now in the form of a piece of matter moving, but it's just the pressure of the field itself. And so you create a circumstance where it wasn't in a position to create motion, and you made it into a condition that can create motion just by knocking that electron out. And so that's one of the nuances of what you can do when you start breaking nuclei, is that you're creating lots of circumstances like that where you compressed matter, made it more stable, made it less hot. And the fact is, though, all you have to do is knock a couple pieces out of it, and you've made it extremely hot, in the sense that there's a huge amount of energy now that's capable of, creating an elastic reaction, if you want to call it that. It's a spring with no spring, essentially. There's no stored energy, but there's energy, in a sense, stored in the position of the two protons. You've put them in a position that's in that where they can't exist in that position without the electron. If the electron isn't here, they can't exist in those conditions without the neutral force. You don't even need gamma rays. You don't need anything. You just need them to be in space anywhere, and they have to fly apart just from the average density, the average pressure of the force. So they don't even need to be in the middle of a sun or in any place that's highly active. All right, so we'll talk a little bit about suns and pressure. Most of this, look, I'm just doing this to say, look, I think these are credible points to be made about how this might function, that physics is just pretending nothing else can exist but their theory. And I'm going to argue that a discrete particle theory can explain this stuff, and they just haven't tried very hard to make anything like that work. Missing a pen. Okay, so suns are taking in energy from the universe, we could all argue. Okay, and so this is a fundamental argument just about the idea of a bent geodesic, okay, being the explanation for gravity. And I think the obvious, it just should be obvious to physicists, and I'm surprised it's not, that what gravity does is give things momentum. So if I put a satellite in space and it doesn't have enough motion not to crash into the earth, the fact is it's going to gain momentum, crash into the earth with momentum. It's going to create pressure on the surface of the earth. It's creating heat. Okay, so a piece of mass crashing into the earth creates heat. And the simple argument is the force itself, even if I just put a piece of matter on the surface, it doesn't stop creating heat. Okay, it's still pushing on the earth. So even after it's crashed and broke into a million pieces, all those pieces are still pushing as if it was still moving. Now, it's not moving at the same velocity. It's only going 1 mile an hour now. I would argue that's how fast you're going into the Earth. That's how fast you need to move something to weigh its weight. So if I move an elephant at 1 mile an hour into a scale, okay, sideways, it'll weigh elephant. If I move a mouse 1 mile an hour, it'll weigh mouse. Okay, and that's what this is. This is what surface pressure is this 1 mile an hour of velocity, of momentum, and all of that momentum is constantly pushing. So each piece of matter that's not in the center of the Earth, all of it is constantly moving towards the center of the Earth. And you could argue that some of it's trying to get back out. Okay, so some of it made it through the center and is trying to get out. Okay, and so there's energy moving through the Earth trying to get out. Now the whole point is as I described earlier in my model, you could understand that any time a force is free, it's moving the speed of light. Okay, but if it's pushing matter, it's moving much less. 10% could be 2%, could be 1%, could be a lot smaller. So it's going a very much smaller velocity. Okay, so it can't travel distance at the same speed at the same amount of time. So obviously, if I had a photon that was going through this, if I was just going to travel the diameter of the Earth, it would get here in whatever that time is, very fast. That's unfortunate, not quite in the picture. Just get rid of some of that. All right, so there's a photon going to travel through the Earth. Well, I just can't win today. That should have been dark enough. Don't know. Yeah, there's some bug there, some real defect. Anyway, there you can see. You can see it. All right, so and then, but if it's going through the Earth, you got to understand it's going to be pushing matter, and the matter is going to go a lot slower. So in the same time, it's only going to go this far. So you can sort of understand, I would think, the simple argument that obviously thermodynamically the Earth is trapping force. It's collecting it because the energy of the universe can't get through the Earth at the same speed that it usually travels distance. So it's collecting a whole bunch of force from the universe is getting trapped inside of the Earth. So the density of force inside any gravitational body is much higher because the force is stuck to matter and it's moving very slowly. So it hasn't lost energy in any way. It's just lost velocity and it's lost time. And the fact is that's what you're stuck in gravity, is a time differential. You're always one push behind. So you push into the Earth can't push you back immediately because the energy that would have pushed you back, say if you were in empty space, something pushes you this way, something's immediately pushing you back the other way. And in this case, okay, because one push is going to be right now, this is the amount of pressure on one side of the universe, the pressure on this side doesn't get to you in time because it's stuck inside the Earth. And so you have the latitude of pushing in until that time catches up, okay? Then the universe pushes back, but it's still one push behind because while it was pushing you back, you got pushed in a new round of pushing in. So it's always one behind. So it's just a time differential. It takes time for force to get through the matter. So in this instant of time, the force that would have balanced me, would have kept me floating, can't get to me. It hasn't gotten to me yet. Okay, it's trying to get to me, but it can't because it's stuck inside the Earth. And so the Earth is basically, any material object, big, ends up just collecting force because it's moving slower through it. So it's collecting a higher density of it. So as a place in space, this piece of empty space only has, 6 pieces of force flying through it. All right. And because of the construction of the Earth, it will have 16 or whatever the number will be. It'll have much more force in that hunk of space because there's a bunch of force that's time delayed, and it's stuck trying to get through the Earth. So I think that's E equals mc squared. That's the real cause of, or creation of, energy. And it's clearly gravity creates energy in the sense that it creates the heat and the pressure, and all that happens is it stores it and radiates it. Okay, and that's it. But it's always, that's the gravity part. And so in absorbing energy, heat, okay, that's the part creating the gravity. So because the Earth is collecting fuel, and how does the fuel radiate? Well, yes, it obviously does radiate back out into the universe. So, and that's the light. And because the Earth isn't quite dense enough, isn't quite enough matter, it can't collect enough heat to create visible photons. So it doesn't. And it's only because the sun is hot enough that it ends up making a bunch of the atoms glow, and we see that as free energy from the sun. But the Earth is radiating also a bunch of energy. It's just that it's not at the same frequencies. A bunch of heat. Okay. And that's the big difference. So there's a lot of visible light coming out of the sun, and it's that visible light that we are sensitive to that our atmosphere collects. All right, so that's another argument. This guy talked a little bit about global warming, and like almost as if, please don't even bother watching my videos if you're such an idiot and you don't realize it's actually happening, man-made. And I would argue, though, there's a real missing piece in all of that. So it's a little bit not related, but I'll just throw this in. Even who knows if you're listening still. So again, this might just be a waste of my time, so I'm not going to go into all the details I could go into. But I would make the argument that the problem with fusion, okay, one of the problems it has, that's really significant, is that to create this high pressure and to try to duplicate the sun, so even if you started creating your heat engine, the fact is you really don't have any way to control all the losses you're going to create in trying to maintain this system. So it's going to be a very hot machine. So even nuclear power, big giant evaporating towers, lots of heat going into the atmosphere. And what's really causing global warming is the hot atmosphere. Okay, now carbon dioxide is it's not good, but CO2 is not a great storer of energy. So it's not a great greenhouse gas. And I would argue that the real key to what's happened because of our industrialization, the problem isn't the CO2. The problem is that all those smokestacks are hot. They're pumping heat into the atmosphere. And the real greenhouse gas is really just a greenhouse vapor. And it's called water. Okay, the water, that's the thing that's holding all of the energy, the thermal energy. So it's anything that creates heat in the air ends up going. The ocean is 70% of the Earth's surface, or something like that. Water is. Well, water's even higher. Okay, the ocean, and so the surface of the Earth is covered with a surface capable of producing humidity. Very little of the Earth is desert. So, any heat you put into the atmosphere is basically just going to bang on that water. So the water's cold, and the air is hot. Okay, and the hot air is going to hit the cold water, and it's going to push, more water into the air, and the air is going to get more and more humid, and that humidity stores solar energy, and that's the greenhouse effect. So water is the real enemy in terms of the chemical in the atmosphere that we're going to increase. So the Earth in 300 million years ago, before the carbon was sequestered into the ground, the key difference is that the Earth was really hot and really humid, and that's what's going to happen again. That's what we're recreating, is those conditions. It's the heat of the atmosphere that makes it hold more water, and more water means more heat stored, and the more heat you store, the more heat you're going to have the next day when the sun hits it again and heats it up. So that's the heat engine. And yeah, it's the stored energy that we've released. It's the carbon in a way. This isn't helping any, but it's mostly the fact that to release the carbon, you release a tremendous amount of heat. And yes, you're using it to turn turbines and to make electricity, but a big ton of it's going to end up just heating the atmosphere in the end. So when you turn on your electric drill, yeah, you made heat at the power plant, you made heat at the transformer, and now you're making heat again when you use the drill. And all that heat doesn't just dissipate. It ends up hitting water and knocking it into the atmosphere. That would be my argument. That's the bigger greenhouse conundrum. All right, so let's see where I'll go next. I probably shouldn't even have to, make this argument just about the fact that, the evaporating towers are nuclear power plants. So they're either by the ocean or by some water source that's cold, because it's a tremendous amount of waste heat. So they gush a huge heat profile into the environment. So they're not as green as people think. Not that I'm against nuclear. I'm just arguing that you have to understand, this is the real liability, that putting any heat in the atmosphere means you've made more greenhouse gas in the form of water vapor. I mean, water vapors really is probably one of the top 10 substances you can put in the atmosphere to hold heat. So obvious. I shouldn't even have to argue it. So let me just reiterate this gravity argument. Because I didn't really point out how you can't say bent geodesic causes gravity. It's ridiculous in a way, because the gravity creates heat. It's what creates the heat inside the Earth. Now people argue that, it's a bunch of radioactive elements and they're doing a bunch of, decaying, and that radioactive decay heats the Earth. No, it's certainly likely that as soon as you start liquefying something, obviously density, atoms that are heavier are going to be able to sink, and atoms that are lighter are, going to do their thing. But then when something's spinning, then you have the opposite problem where, your heavy things are now going to be thrown to the outside. So it gets a little complicated. But regardless, you can understand that they're just saying so, and there's no evidence of so. And the argument I would make is that this radiation should be able to leak its way out if it was all made by some kind of radioactive isotopes falling apart. All right. And so, look, the real answer is the gravity itself is pressure. You can understand the pressure inside the center of the Earth is insanely high, because all this gravitational energy pushing on electrons and protons, making them move towards the center, and then it's matter pushing matter, right? You have a bunch of electrons and protons, atoms, pushing on each other, which is the force, the reflective force of the electrons, which is perfectly elastic, so they don't absorb the force, they can't accept the force. And obviously, but when you get into the center, obviously it's going to be a much denser material. But then that density has all this heat involved with it, all this motion. So the motion means lots of banging into each other. So even though it wants to compress, it can't compress because it keeps bouncing. That's the nature of how the universe works. So they say the universe is going to die of a heat death because somehow nothing's creating heat. And it's just obvious that gravity's creating heat. A huge amount of heat. Huge. And it's heat that the universe runs on. So gravity creates it by consolidating it in these smaller spaces, right? It pushes a bunch of matter, moves a lot slower. So there's a lot more of it inside the matter bits. It's basically stored force in there, okay? And now every time one of those things explodes or does something, all of that energy is released, okay, back into the universe to push on something else. So everything else is going to get pushed in by the same energy, okay, that is flying out of something else. And it's just the universe ends up in an equilibrium of compressing matter in one case and then breaking matter in another case. And so it's basically the fission cycle. Make it and break it, make it and break it. And I'd argue that fusion is essentially, look, they're not using, they say they're taking advantage, they're going to combine hydrogen and make helium. Well, that's, they're not really talking about real hydrogen, right? I mean, this is hydrogen, a single proton. They call that hydrogen. It's not hydrogen. This really should show up better. I have to fix this. Alright, so that took so long that I don't even remember what I was talking about. But I think it just has something to do with the fact that you can't claim it's bent space because the sun and the earth and every other planet that's of any size is radiating heat. Heat created by gravity. And that you have to have some way to turn that into bent space. And how do you do that? Besides just saying, why not just use it as heat? So it's all just radiation. It's all different forms of electromagnetic radiation. And that scale, right, doesn't really have, you could argue there can be things on that scale that don't have a frequency. And then how could we measure them, right? So if I could argue that the frequency is, and the wavelength is created by a timed event, that is stuff moving through space, this would be, say, infrared radiation, and, ultraviolet would just be this version of this. That all you're doing is compressing the force in space. So I could just say that, photons are hitting my hand. I move my hand forward at the speed of light. I would collect all the energy because my hand's moving the same speed as the force is reflecting. The force can't get anywhere. And if I stop my hand, all of the bits would fly off at exactly the same time and be a huge compression in terms of an amount of energy hitting something all at once. All right, so it seems kind of, that works. And so that's all that's happening in the universe is just this heat is being recycled and changing its frequency and density. And that's all that's really happening. And there's no bent space. There's just heat going through this compression cycle of moving matter. And once the matter's moving, it moves into each other. Okay. By the very fact that it's slowing a force down, collecting a force. And, it works as a theory. I mean, if I took a box full of BBs that could bounce off the surface and always move the same speed, I could just throw 2 apples in there and they'll move into each other. So we know it works. And, to consolidate matter. And so it's, pretty simple that when the matter falls apart, it's going to fall apart, demonstrating how much force there really is in that space in the universe, and how much colder it should be, that it's already hot. I don't know the best way to say that. But like I said, there's a nuance to it in the terms of the compressed matter has stored less matter, but it's more vulnerable to displaying how much energy is in the field, because as soon as you break the arrangement, the nice proton, electron, proton, proton, electron, proton, the arrangement, you break that, then the real energy of the universe is revealed, and the matter flies apart aggressively. All right, it's probably enough as a... Come on. This stuff is worth discussing. Let's just do kinetic energy real quick. I mean, all the arguments. Ballistic pendulum fails to collect the energy. So I make a big heavy thing. I put this thing with 2,000 joules into it. I lose 99.94% of the kinetic energy. Gone. Missing. They say it's heat, but they don't measure it. So all I get is the momentum back. So I conserve the momentum, I lose 99.94% of the kinetic energy. Levers. Okay, so I put a 4 mass going 1 velocity, and then I have a 1 mass going 4 velocity. Those two things will oscillate perfectly, hundreds of times. Obviously demonstrating that these two things equal each other, that's the same amount of energy. Leibniz 350 years ago said, no, the things that equal each other is a 1 mass going 2 velocity. Okay, so it's a 1 mass and a 2 velocity. So they don't have the same momentum. They won't oscillate on a lever. It doesn't work. But Leibniz says so. Okay, that 4 mass dropped 1 foot is the same as a 1 mass dropped 4 feet. Problem is, the 1 mass dropped 4 feet is only going 2 velocity. So they don't have the same momentum. And momentum matters. Thrust. Okay, you have thrust on a rocket engine. Okay, if you calculate its kinetic energy, it won't tell you anything useful. Okay, because the rocket will not move with the kinetic energy. If you calculate the momentum, then Newton's third law will work. And whatever the momentum of your particles you threw out, this will be your momentum of your spaceship. So the third law will work, and you'll get an equal and opposite reaction, and you'll successfully land on the moon. Calculate the kinetic energy and assume that the kinetic energy obeys Newton's third law, and you have no luck at all. You have no hope at all. Bowling ball, 8-pound bowling ball, 16-pound bowling ball. 8-pound bowling ball going 16, 8-pound going 8-pound going 16, 16-pound going 8. I roll them into a pins, and the only thing they're going to transfer is the momentum. They can't transfer anything else. There's nothing else they can transfer but their momentum. The fast bowling ball will make the first pin go away fast. It'll carry away lots of momentum. The ball go a lot slower. So the ball loses more energy because it gives the pin more energy. The slower one gives away less, gives the pin less, but it keeps going and keeps going and keeps going, giving away energy. So clearly proving no kinetic energy. It's nonsense. It's not real. It's yes, fast things can break things better, but fast things don't have more energy. Faster, lighter things. And then the perfect example is the 5 mass going 10V tug of war with a 10 mass going 5V. Their theory says, okay, this has twice as much energy, 2x. It should clearly win the tug of war. Can't happen, doesn't happen. No evidence that the kinetic energy can do real work. Zero evidence it can do real work. Zero evidence that 5 times the fuel that I have to use 25 times the fuel to make something go 5 times as fast, and certainly no evidence that something going 5 times faster does 25 times the work. So 1/2 mv squared, okay, is a fable. It is nonsense. It's a holy ghost in the middle of physics. It has no reason to be there. It's no credibility. It doesn't work. It doesn't happen. It's not physics. It's a religion. Nonsense. So I'd love it if you could explain how that's wrong. Well, let me just go further with the pendulum argument, because it's just so obvious that, come on, you can't, All right, so I have a 1 mass, and then I have a 6 mass. And I collide the 1 mass into the 6 mass, okay, with 100 momentum. And what do I get? I get 200 momentum in the 6 mass. Pretty close to it, 198, whatever the calculation is. The more classic example is a 1-3, and that's 150. But I'm just using the maximum amount. And then what do I get? I get 100% of my energy back. So if I do it in gravity, that is, I let gravity restore my energy for me, it'll just keep doing this. Okay, and I can launch 1 6-pounder, a second 6-pounder, a third, a fourth, a fifth. I can just keep on banging into heavier things and making more free energy. Can't happen, doesn't happen, it's nonsense, it's ridiculous physics. I've been saying this for years, and none of you people will in any way engage in these arguments and explain how your physics can save itself from this ridiculous statement that all I have to do is hit a heavy thing and I can make more momentum in a direction because somehow this cancels. I fire a gun, the bullet flies out, right? I can just cancel the two momentums, the recoil of the gun and the bullet. I cancel them and say there's zero momentum in the universe. That's how ridiculous this is. You're basically saying I only put 100 in, I get 300 out. I fire the gun with 100. That's the only fuel I put in is 100. The one object flies off with 100, and the other one flies off with 200. This is my fuel. This is what's firing the gun. This is creating all of the energy that these two objects will ultimately have. How can I put 100 in and get 300 out? It's ridiculous. Alright, so that's probably enough of a video. I hope it was polite enough and such, and so forth and whatnot. So, you know, so much of this physics needs to be talked about, and they don't talk about any of it.